Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have triangle ABC. We also know that side AB of this triangle ABC equals to 13 units in length, side BC equals to 14 units in length, and side AC equals to 15 units in length. Our mission is to find out the area of this green shape. Okay, so we start with the first method, and I will present to you a new rule, and we will implement the new rule in our drawing. According to the new rule, that is actually rule number 4, the area of triangle ABC is equals to this expression. So here we have triangle ABC. The length of side AB is A units, side BC equals to 2 units in length, side AC equals to 3 units in length. And here this S equals to the semi-perimeter of this triangle ABC. The semi-perimeter of any triangle, it is equals to the perimeter over 2. The perimeter of any triangle equals to the sum of its side lengths. This triangle ABC is this A plus B plus C, and when we will divide the perimeter by 2, we get the semi-perimeter S of this triangle ABC. So S equals to A plus B plus C over 2. A is the length of side AB, B is the length of side BC, and C is the length of side AC. Therefore, the area of this triangle ABC equals to the square root of S, that is the semi-perimeter of this triangle ABC, that is A plus B plus C over 2, times S minus A, times S minus B, times S minus C, all under the root. So actually can implement rule number 4 in our drawing. Why? Because in our drawing we will define side AB as A, and we know that A equals to 13 units in its length. We define the length of side BC as B, and we know that B equals to 13 units in its length. And finally, we define side AC of this triangle ABC as C, and we know that C equals to 15 units in its length. So I write it down. Side A equals to 13 units in its length. Side B in triangle ABC equals to 14 units in its length. And finally, side C equals to 15 units in its length. And the semi-perimeter of this triangle ABC S equals to A plus B plus C over 2. A is 13 plus B that is 14 plus C that is 15 over 2. 13 plus 14 is 27. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter S of our triangle ABC equals to 21 units. S equals to 21 units. And A equals to 13, B equals to 14, and C equals to 15 units. So the area of our triangle ABC, the square brackets is the sign for the area, according to rule number 4, according to the new formula, must be equal to the square root of S times S minus A times S minus B times S minus C. So the area of triangle ABC will be equal to the square root of S. S is 21. Again, S is 21 minus A. A is 13. So S minus A in total is 21 minus 13. times S minus B. S is 21 and B is 14. So in total S minus B is 21 minus 14. Times S minus C. S is 21 and C is 15. So in total S minus C is 21 minus 15. So according to this new formula, the area of our triangle ABC equals to this expression. So the area of our triangle ABC is equals to the square root of 21 times 21 minus 13 is 8 times 21 minus 14 is 7 times 21 minus 15 is 6. So actually the area of triangle ABC in total it is equals to the square root of 21. We'll substitute 21 by 7 times 3 times 8. We'll substitute 8 by 2 times 2 times 2 times 7 times 6. We'll substitute 6 by 2 times 3. So if we found out that in total the area of triangle ABC, according to the new formula, it is equals to the square root of 7 times 7 times the square root of 3 times 3 times the square root of 2 times 2 times the square root of 2 times 2 again. So the area of triangle ABC in total, according to the new formula, is equals to the square root of 7 times 7 is 7, times the square root of 3 times 3 is 3, times the square root of 2 times 2 is 2, times the square root of 2 times 2 again is 2. So actually we found out that the area of our triangle ABC is equals to 3 times 7 is 21, 21 times 2 is 42, and 42 times 2 is 84. So the area of our triangle ABC, in total it is equals to 84 square units. Okay. The area of this triangle ABC, it is equals to 84 square units. In the next step, I will present to you a new rule and we will implement the new rule in our drawing. We have here rule number 6. According to this rule number 6, the radius of a circle that blocks triangle ABC is equals to capital R. This is the radius of the circle that blocks this triangle ABC equals to A times B times C over 4 times the area of this triangle ABC. Here, side AB equals to A units inside, side BC equals to B units inside, side AC of this triangle ABC equals to C units inside. So A times B times C is the multiplication of the side lengths of this triangle ABC by each other. Over 4 times the area of this triangle ABC. So in order to find the radius of a circle that blocks triangle ABC, it could be any triangle, you will multiply the side lengths of the triangle that is blocked by the circle by each other, A times B times C, over 4 times the area of this triangle ABC that is blocked by this circle. So we actually can implement rule number 6 in our drawing. Why? Because in our drawing we have this circle that blocks triangle ABC. So we define the radius of this circle as capital R. According to rule number 6, capital R must be equals to A times B times C over 4 times the area of this triangle ABC that is blocked by this circle. Repeat again that according to rule number 6, the radius of our circle that blocks triangle ABC must be equal to A times B times C, that is the multiplication of the side lengths of triangle ABC that is blocked by the circle over 4 times the area of triangle ABC that is blocked by our circle. So capital R equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. We have already found out that the area of our triangle ABC, it is equal to 84 square units. So it is 4 times the area of triangle ABC, that is 84 square units. In the next step, we will divide both the numerator and the denominator of this expression by 14. And here 14 over 14 is 1, so in the numerator we left only with 13 times 15 over 4 times 84 over 15 is 6. In the next step, we divide both the numerator and the denominator of this expression by 3. And we get that in the numerator we have 13 times 15 over 3 is 5, over 4 times 6 over 3 is 2. 13 times 5 is 65, and 4 times 2 is 8. So in total we found out that the radius of this circle capital R, it is equal to 65 over 8 units. Okay, and our mission is to find out the area of this green shape. From the drawing, it is very easy to see that the area of this green shape it is equal to the area of the circle minus the area of triangle ABC. Repeat again. The area of the green shape in total, it is equal to the area of the circle minus the area of triangle ABC. The area of the circle is pi r squared minus the area of triangle ABC. We already found out that the area of triangle ABC is 84 square units. So it is pi times r squared. R is 65 over 8, therefore r squared is 65 over 8 squared minus 84. So this expression, pi times 65 over 8 squared, in total it is equal to 207.394 square units minus 84. 207.394 square units minus 84 square units, it is equal in total to 123.394 square units. And that is the answer to our question. That is to say, the area of this green shape, it is equal to 123.394 square units. So we finish with the first method. In the next step I will present to you how to find out the area of this green shape according to the second method. In the second method, we'll do a construction. That is to say, from point A, we will go perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point A and BC as M. We'll define the length of side BM as X. We know that BC equals to 14 units. So MC, here, the length of this line segment MC must be equal to BC minus BM. Again, BC minus BM is MC. So MC is BC, that is 14, minus BM, that is X. So in total, MC equals to 14 minus X. MC equals to 14 minus X units in its length. We define side AM as H. In the next step, I will copy the right triangle, triangle A and B in the new page, and we will implement on this right triangle, triangle A and B the Pythagoras theorem. So actually, this is the right triangle, triangle A and B that they comment from the original drawing. Side AB equals to 13 units in itself according to what is given us in the question. AM equals to H according to our definition, and BM equals to X also according to our definition. Here by PT is a version from Pythagoras theorem. According to the Pythagoras theorem, in this right triangle, triangle A and B, AB square, this will be question number 1, AB square equals to AM square plus BM square. AB is 13, therefore AB square is 13 square, that is 169, and it is equals to AM square. AM is 8, therefore AM square is 8 square, plus BM square. BM is X, therefore BM square is X square. So in total we found out that according to equation number 1, 169 equals to H square plus X square. We subtract X square from this equation, equation number 1, and we get that according to this equation, equation number 1, H square equals to 169 minus X square. In the next step, I will copy the right triangle, triangle AMC in the new page, and we will implement on this right triangle, triangle AMC the Pythagoras theorem. So actually, this is the right triangle, triangle AMC that I got from the original drawing. MC equals to 14 minus X units in itself, AM equals to H according to our definition, and it is given us the equation that the hypotenuse AC equals to 15 units in its length. According to here by PT evolution from Pythagoras theorem, according to the Pythagoras theorem, in this right triangle, triangle AMC, AC square equals to AM square plus MC square. So AC is 15, therefore AC square is 15 squared, that is 225, and it is equal to AM square. AM is h, therefore AM square is h square plus MC square. MC is 14 minus x, therefore MC square is 14 minus x square. Here we subtract 14 minus x square from this equation, equation number 2, and we get that according to this equation, equation number 2, h square equals to 225 minus 14 minus x square. This is according to equation number 2. But we have already found out that according to equation number 1, h square equals to 169 minus x square. So we have two different expressions for h square. So in the next step we will create equation number 3. According to equation number 3, h square according to equation number 1 must be equal to h square according to equation number 2. So h square according to equation number 1 is equals to 169 minus x square, and it must be equal to h square according to equation number 2. H square according to equation number 2 is equals to 225 minus 14 minus x square. So actually found out that according to this equation, equation number 3, 169 minus x square equals to 225 minus, we'll open the brackets here, 14 minus x square equals to 14 squared, that is 196, plus x square minus 2 times 14x, that is minus 28x. So actually found out that according to this equation, equation number 3, 169 minus x square equals to 225. Here we'll open the brackets here. It will be minus 196 minus x squared, minus and minus is plus, so it is plus 28x. So here we have minus x squared on both sides of the equation, so x squared will get cancelled. After we cancelled x squared, in this side of the equation we left only with 169. That is equals to 225 minus 196 is 29, plus 28x. Here we subtract 29 from this equation, equation number 3, and you get that according to this equation, equation number 3, 169 minus 29 is 140. So 140 equals to 28x. Here we divide this equation by 28, and we get that x, according to this equation, equation number 3, equals to 140 over 28 is 5. So x equals to 5 units. So according to equation number 1, we have already found out that h square equals to 169 minus x square. That is to say, h square equals to 169 minus x square, but x is 5, therefore x square is 5 squared, that is 25. So in total, h square equals to 169 minus 25, that is 144. So actually, found out that according to equation number 1, h square equals to 144. Here we'll take a root out of this equation, and we get that h equals to the square root of 124, that is 12. So h equals to 12 units in its length, and x equals to 5. Here, h equals to 12 units, and x equals to 5. In the next step, we will define the center of this circle as O. We'll join points O, A, and O together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle. We'll extend the radius OA by straight line until it touches the circle here. We define the touching point of the extended radius AO in this circle as point P. We created here, by doing this construction, we created chord AP. This chord AP, passes through point O, that is the center of this circle, and any chord that passes through the center of the circle must be the diameter of the circle. That is to say, AP is the diameter of the circle. So we can write here that AP is the diameter of the circle. The diameter of any circle is twice as long as the radius. The radius of this circle is capital R, therefore AP must be equal to 2 times capital R. AP equals to 2 times capital R. This line segment AP is the diameter of the circle that equals to 2 times capital R. In the next step, we'll join points P and C together by a straight line. By joining points P and C, we created the peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, it is equals to 90 degrees. So actually, this can implement rule number 7 in our drawing. This peripheral angle ACP rests on AP, that is the diameter of the circle, therefore according to rule number 7, it is equals to 90 degrees. So this peripheral angle ACP is equals to 90 degrees in its size. We can implement here also rule number 8. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. In the drawing we have peripheral angle ADB that rests on chord AB, and it is equal to theta. And we also have another peripheral angle ACB that rests on the same chord AB. So whenever you have two peripheral angles that rest on the same chord, they must be equal to each other. That is to say, peripheral angle ADB must be equal to this peripheral angle ACD. That is to say, is this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. Again, according to rule number 8, whenever we have two peripheral angles that rest on the same chord, then they must be equal to each other. In this case, those two peripheral angles rest on the same chord AB, therefore they are equal to each other. Both those two peripheral angles, they are equal to theta. So we can implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC. This peripheral angle APC rests on chord AC. And we also have another peripheral angle ABC, that also rests on the same chord AB. Therefore, those two peripheral angles must be equal to each other because they rest on the same chord called AC. So if this peripheral angle APC equals to theta, then this peripheral angle ABC also must equal to theta. So if you focus on the right triangle, triangle ABM, in this right triangle, triangle ABM, this angle equals to 90 degrees. This angle equals to theta, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, if you focus on the right triangle, triangle APC, in the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the right triangle, triangle BAM, is similar to the right triangle, triangle PAC. So why those two right triangles are similar to each other? So write it now. We'll prove that the right triangle, triangle ABM, is similar to the right triangle, triangle APC. So, why those two right triangles are similar to each other? First of all, those two angles, they are both equal to theta, therefore they are equal to each other. So, you can write down that angle ABM, triangle ABM, is equal to this angle, angle APC, triangle APC. Repeat again. Angle ABM and triangle ABM equals to angle APC, triangle APC. They are both equal to theta, therefore they are equal to each other. In addition, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle AMB is equals to this angle, it is actually angle ACP. Repeat again, angle AMB and triangle ABM equals to angle ACP and triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle BAM is equals to this angle, angle PAC. Repeat again. Angle BAM and triangle ABM equals to angle PAC and triangle APC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in triangle ABM are correspondingly congruent to all the three angles in triangle APC. Therefore actually proved that the right triangle, triangle ABM, is similar, this is the sign of similar, to the right triangle, triangle APC, according to angle similarity rule. Okay? And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that AB in triangle ABM over AP in triangle APC equals to AM in triangle ABM over AC in triangle APC. I'll repeat again. We derive that AB over AP equals to AM over AC. So AB is 13 over AP, that is 2R, it is the diameter of the circle, and it is equal to AM. AM is 12 over AC, that is 15. So in conclusion, we found out that 13 over 2R equals to 12 over 13, to 12 over 15. Here we cross multiply this equation, and we get that 13 times 15 equals to 12 times 2R. Here we divide this equation by 12, and finally we get that 13 times 15 over 12 equals to 2R. Here we divide this equation by 2, and finally we get that R, that is the radius of this circle, equals to 13 times 15 over 12 times 2. Here we will divide both the numerator and the denominator of this expression by 3, and we get that in the numerator we have 13 times 15 over 3 is 5 over 2 times 12 over 3 is 4. So here we have 13 times 5, that is 65, over 4 times 2, that is 8. So in conclusion, we found out that the radius of this circle, that is to say capital R, is equals to 65 over 8 units. Repeat again, the radius of this circle capital R, it is equals to 65 over 8 square units. And what is the area of the green shape? The area of the green shape in total, it is equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of this green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r squared minus the area of triangle ABC. We already found out that the area of triangle ABC equals to 84 square units. R is 65 over 8, therefore r square is 65 over 8 square. That is the area of the circle minus 84, that is the area of triangle ABC. So actually 65 over 8 square times pi, in total it is equals to 207.394 square units minus 84. 207.394 minus 84, in total it is equals to 123.394 square units. And this is actually the answer to the question, that is to say the area of this green shape equals to 123.394 square units. So in the next step I will summarize the lecture. We start with the first method, of course. in the drawing, we have this circle. Inside this circle, we have triangle ABC that is blocked by this circle. Side AB of this triangle is equals to 13 units. Side BC equals to 14 units in sums, and side AC of this triangle ABC equals to 15 units in its length. Our mission is to find out the area of this green shape. It's very clear from the drawing that the area of the green shape equals to the area of the circle minus the area of triangle ABC. So, I presented to you rule number 4, we implemented rule number 4 in our drawing. We have here triangle ABC. In this triangle ABC, side AB equals to units in itself, side BC equals to units in itself, and finally side AC equals to 3 units in itself. According to this rule number 4, the area of this triangle ABC must be equal to the square root of S times S minus A times S minus B times S minus C, all under the root. While S is the semi-perimeter of this triangle ABC. What is the definition of a semi-perimeter? The definition of a semi-perimeter is the perimeter over 2. The perimeter of this triangle is the sum of its side lengths, that is to say it is A plus B plus C. And if we divide the perimeter by 2, we get the semi-perimeter, that is S. S is abbreviation for semi-perimeter. So the semi-perimeter S of this triangle ABC, S equals to A plus B plus C over 2. A is the length of side AB, B is the length of side BC, and C is the length of side AC of this triangle ABC. So, we actually can implement this new rule number 4 in our drawing. Why? Because in our drawing we define the length of side AB as A, that is 13 units. We define the length of side BC of triangle ABC as B, that is 14. And we define the length of side AC of this triangle ABC as C, and C equals to 15. Repeat again, according to our definition, A equals to 13, B equals to 14, and C equals to 15. In the next step, we calculated the semi-perimeter of this triangle ABC. According to the rule number 4, the semi-perimeter of our triangle ABC must be equal to A plus B plus C, that is the perimeter, over 2. A is 13, B is 14, and C is 15. If we divide the perimeter by 2, we get the semi-perimeter S. 13 plus 14 is 27, and 27 plus 15 is 42. 42 over 2 is 21. So finally we found out that the semi-perimeter of this triangle ABC is 21 units. S equals to 21. A equals to 13, B equals to 14, and C equals to 15. And according to the new formula, rule number 4, the area of our triangle ABC must be equal to the square root of S times S minus A times S minus B times S minus C. S is 21. So according to the new formula, the area of our triangle ABC must be equal to S, that is 21, S minus A, S is 21, and S is 13, so S minus A is 21 minus 13. S minus B, S is 21 and B is 14, so in total S minus B is 21 minus 14, times S minus C. S is 21, C is 15, so in total S minus C is 21 minus 15. So the area of triangle ABC equals to the square root of 21. 81 minus 13 is 8. Again, 21 minus 13 is 8. 21 minus 14 is 7. And 21 minus 15 is 6. Here we substitute 21 by 7 times 3. We substitute 8 by 2 times 2 times 2 times 7, and we substitute 6 by 2 times 3. So the area of triangle ABC must be equal to the square root of 7 times 7 times the square root of 3 times 3 times the square root of 2 times 2 times the square root of 2 times 2 again. The square root of 7 times 7 is 7, the square root of 3 times 3 is 3, the square root of 2 times 2 is 2, and the square root of 2 times 2 again is 2. So in total the area of our triangle ABC must be equal to 7 times 3, that is 21, 21 times 2 is 42, and 42 times 2 is 84. So in conclusion, we found out that the area of our triangle ABC is equal to 84 square units. Then I presented to you a new rule, and we implemented the new rule in our drawing. According to the new rule, here we have this triangle ABC that is blocked by this circle. The radius of this circle is capital R according to our definition. The length of side AB is A units, side BC equals to B units in itself, and side AC equals to C units in its length. According to this rule, rule number 6, the radius of a circle that blocks triangle ABC is equals to capital R equals to A times B times C over 4 times the area of this triangle ABC that is blocked by this circle. Okay, so we can actually implement the new rule in our drawing. Why? Because in our drawing we have this circle that blocks this triangle ABC. So if we define the radius of this circle as capital R, then capital R according to rule number 6 must be equal to A times B times C over 4 times the area of this triangle ABC that is blocked by this circle. Repeat again, according to rule number 6, the radius of our circle that blocks triangle ABC must be equal to A times B times C, that is the multiplication of the side lengths of triangle ABC that is blocked by the circle over 4 times the area of triangle ABC that is blocked by the circle. This is according to rule number 6. So capital R, that is the radius of the circle that blocks triangle ABC, must be equal to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. And we have already found out that the area of triangle ABC, is equal to 84 square units. So it is 4 times the area of triangle ABC, that is 84 square units. So here we divided both the numerator and the denominator of this expression by 14. So here 14 over 14 is 1. So in the numerator we left only with 13 times 15 over 4 times 84 over 14 is 5, is 6. 84 over 14 is 6. So in total the denominator we left only with 4 times 6. In the next step, we divided this both the numerator and the denominator of this expression by 3. So we have 13 times 15 over 3 is 5. So in total in the numerator we left only with 13 times 5 over 4 times 6 over 3 is 2. So in total in the denominator we left only with 4 times 2. 13 times 5 is 65 and 4 times 2 is 8. So in total the radius of this circle capital R that blocks triangle ABC is equal to 65 over 8 units. What is the area of the green shape? The area of this green shape, it is very easy to see from the drawing that the area of this green shape equals to the area of the circle minus the area of triangle ABC. Repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. So the area of the green shape equals to the area of the circle. The area of the circle equals to pi r square minus the area of triangle ABC. We already found out that the area of triangle ABC equals to 84 square units. So it is pi r square. R is 65 over 8, so r square is 65 over 8 square. So in total, the area of the circle equals to pi times 65 over 8 square minus 84, that is the area of triangle ABC. This expression in total equals to 207.394 square units minus 84. So 207.394 minus 84 equals in total to 123.394 square units. So in conclusion, we found out that the area of this green shape equals to 123.394 square units. So we finished with the first method. In the next step, I presented to you how to find out the area of this green shape according to the second method. In the second method, we did the construction, that is to say from point A, we draw perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in BC as M. Then we define side BM as X. BC equals to 14, BM equals to X. Therefore, MC must be equal to BC minus BM. That is to say, MC equals to BC, that is 14, minus BM, that is X. So in total, MC equals to 14 minus X. MC equals to 14 minus X. Then I copied the right triangle ABM in a new page and we implemented on this right triangle ABM the Pythagoras theorem. We defined side AM of this triangle ABM as H. So actually, this is the right triangle A and B that I copied from the original domain. Side AB equals to 13 units in itself according to what is given as a question. AM equals to H according to our definition. And BM equals to X also according to our definition. So in the right triangle AB by PT's abbreviation for Pythagoras theorem, according to the Pythagoras theorem, in this right triangle ABM, AB square equals to AM square plus BM square. AB is 13, therefore AB square is 13 square, that is 169, and it is equal to AM square. AM is 8, therefore AM square is 8 square, plus BM square. BM is X, therefore BM square is X square. So in total, according to equation number 1, we found out that 169 equals to H square plus H square plus X square. Here we subtracted X square from this equation. And finally, we found out that according to this equation number 1, H square equals to 169 minus X square. Then I copied the right triangle AMC in a new page and we implemented the Pythagoras theorem in this right triangle AMC. This is the right triangle AMC that is coming from the original domain. MC equals to 14 minus X units. AM equals to H according to our definition. And the hypotenuse AC equals to 15 units. According to what is given as the question. So in this right triangle AMC by PT's abbreviation for Pythagoras theorem, according to the Pythagoras theorem in the right triangle AMC, AC square equals to AM square plus MC square. AC is 15, therefore AC square is 15 square, that is 225, and it is equal to AM square. AM is 8, therefore AM square is 8 square, plus MC square. MC is 14 minus X, therefore MC square is 14 minus X square. Here we subtracted 14 minus X square from this equation and finally found out that according to this equation number 2, H square equals to 225 minus 14 minus X square. This is according to equation number 2, while according to equation number 1, we have already found out that H square equals to 169 minus X square. So we have two different expressions for H square, therefore we created equation number 3. According to equation number 3 states that H square according to equation number 1 must be equal to H square according to equation number 2. H square according to equation number 1 equals to 169 minus X square, and it must be equal to H square according to equation number 2. H square according to equation number 2 equals to 225 minus 14 minus X square. So according to this equation number 3, 169 minus X square equals to 225. Here we open the brackets. Actually, 14 minus X square equals to 14 square, that is 196, plus X square minus 2 times 14X, that is minus 28X. So 169 minus X square equals to 225. We opened the brackets here. It will be minus 196 minus X square. Minus is plus, so it is plus 28x. Here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. So in this side of the equation we left only with 169, and we have 225 minus 196 is 29 plus 28x. Here we subtracted 29 from this equation number 3, and found out that 169 minus 29 is 140, that is equal to 28x. So 140 equals to 28x. We divided this equation number 3 by 28, and finally we got that x equals to 140 over 28 is 5. So x equals to 5 units. And we have equation number 1. According to equation number 1, x squared equals to 169 minus x squared. That is to say, h squared equals to 169 minus x squared. X is 5, therefore x squared is 5 squared, that is 25. So in conclusion, according to equation number 1, h squared equals to 169 minus 25, that is 144. So in conclusion, found out that according to equation number 1, h squared equals to 144. We took a root out of this equation and finally found out that h equals to the square root of 144, that is 12. So here h equals to 12 units and x equals to 5. Then we define the center of this circle as O. We join points O and A together by straight line. Point O is the center of the circle, point A is the point of the circle, and center for OA is the radius of this circle that we defined as capital R. Then we extended the radius AO by straight line until it touches the circle point P. So AP is a chord that passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of this circle, AP is the diameter, and the diameter of the circle is twice as long as the radius. The radius of this circle is capital R, therefore the diameter AP must be equal to 2 times capital R. Okay, then we join points P and C together by straight line. In this way, we created peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have here rule number 7. According to this rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equals to 90 degrees. Here we have peripheral angle ACP that rests on AB, that is the diameter of the circle. Therefore, peripheral angle ACP equals to 90 degrees. We can implement rule number 7 in our drawing. Why? Because in our drawing, we have peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, according to rule number 7, this peripheral angle ACP must be equal to 90 degrees. Then I presented to you rule number 8 and implemented this rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. We have here peripheral angle ADB that rests on chord AB, and we also have another peripheral angle ACB that rests on the same chord called AB. So whenever you have two peripheral angles that rest on the same chord, like in this drawing, then they must be equal to each other. That is to say, those two peripheral angles must be equal to each other. So if peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. So we can actually implement rule number 8 in our drawing. Why? Because in our drawing, we have peripheral angle APC that rests on chord AC, and we have another peripheral angle ABC that rests on the same chord called AC. So those two peripheral angles must be equal to each other. Why? Because they rest on the same chord called AC. So if this peripheral angle is theta, then the other peripheral angle ABC must be also equal to theta. So those two peripheral angles are equal to each other according to rule number 8, because they rest on the same chord called AC. Then we focused on the right triangle ABM. This right triangle, triangle ABM, this angle equals to theta. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle APC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. In the next step, we proved that those two right triangles, that is to say triangle ABM, is similar to triangle APC. Again, triangle ABM is similar to triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the angles in this right triangle ABM are correspondingly equal to all those triangles in triangle APC. Therefore, we actually prove that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AB in triangle ABM over AP in triangle APC is equals to AM in triangle ABM over AC in triangle APC. Repeat again, we derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle, that is 2R, AM is 12, and AC is 15. So we found out that 13 over 2R equals to 12 over 15. Here, of course, multiply this equation and found out that 13 times 15 equals to 2R times 12. Here we divided this equation by 12 and we found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2 and finally found out that R equals to 13 times 15 over 12 times 2. Here we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15 over 3 is 5. So in the numerator in total we have 13 times 5 over 2. In the numerator we have 2 times 12 over 3 is 4. So in total in the denominator we left only with 2 times 4. 2 times 4 is 8 and 13 times 5 is 65. So R, the radius of this circle, capital R, is equals to 65 over 8. I repeat again. The radius of this circle, capital R, is equals to 65 over 8 units. What is the area of the green shape? The area of the green shape equals to the area of the circle minus the area of triangle ABC. I repeat again. The area of the green shape in total it is equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square minus the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. Pi r square is pi times r. R is 65 over 8, so r square is 65 over 8 square. So the area of the circle in total equals to pi times 65 over 8 square minus the area of triangle ABC, that is 84 square units. In total, this expression pi times 65 over 8 square equals to 207.394 square units minus the area of triangle ABC, that is 84. 207.394 minus 84 is 123.394 square units. So in conclusion, we found out that the area of this circle, according to the second method also, it is equals to 123.394 square units. Okay? Repeat again. In both methods, we found out that the area of this green shape equals to 123.394 square units. Okay? Thank you very much.